Waveform characteristic number 5, phase. The phase of a waveform is the point at which it is measured or observed in its cycle. So this is maybe a little complicated to understand for the first time. But when a sound wave hits our ears, it's not necessarily hitting right at the exact moment of total pressure, no pressure, or total negative pressure. It's probably landing somewhere in between in its vibrational cycle. The point that it arrives is the point in its phase. Phase is measured in degrees, and it's important to understand because it determines the way that pressure from various sound events interact in the air. And also how they interact within audio equipment once they become electronic signal, which would happen after they were picked up by a microphone, for example. So we have one waveform on our graph. It looks like this. If we were to add a second identical waveform at the same point in its cycle, the result would be double the amplitude, or twice as loud. And this is called in phase. The two waveforms are perfectly in line with each other. They are in phase, and the pressure they create is twice as much. But then in turn, if we have two waves, but this time they're at opposite points in their phase. For example, if one of the events is delayed in time by exactly half of a cycle, then the combination results in no pressure, therefore no sound. This is called being out of phase. When two identical sounds are perfectly out of phase, they totally cancel and create silence. No more pressure. This combining of waves at different points in their cycles will result in a variance of combined pressure, anywhere from doubled to total cancellation and all the values in between. The degree to which waveforms are either in or out of phase with each other is called coherence, or correlation, which just describes the amount of cancellation or addition caused by the relationship between two or more waveforms.